warahmatullahi wabarakatuh. My name is Amirul Ashraaf bin Sulaiman. My matrix number is 01 DBM23 F1020. I am from class DBM2A. My role for this presentation is I will talk about introduction for integrals and application that we can apply in our daily life. Thank you. Introduction for integration. In mathematics, an integral is the continuous analog of a sum which is used to calculate areas, volumes, and their generalization. Integration, the process of computing an integral, is one of the two fundamental operations of calculus, the other being differentiation. Integration was initially used to solve problems in mathematics and physics, such as finding the area under a curve or determining displacement from velocity. Usage of integration expanded to a wide variety of scientific fields thereafter. A definite integral computes the sine area of the region in the plane that is bounded by the graph of a given function between 2 points in the real line. Conventionally, areas above the horizontal axis of the plane are positive while areas below are negative. Integrals also refer to the concept of an antiderivative function whose derivative is the given function. In this case, they are also called indefinite integrals. The fundamental theorem of calculus relates definite integration to differentiation and provides a method to compute the definite integral of a function when its antiderivative is known. Differentiation and integration are inverse operations. Although methods of calculating areas and volumes dated from ancient Greek mathematics, the principle of integration were formulated independently by Isaac Newton and Gottfried Wilhelm Leibniz in the late 17th century, who took of the area under a curve as an infinite sum of rectangles of infinitesimal width. Bernhard Riemann later gave a rigorous definition of integrals, which is based on a limiting procedure that approximates the area of a curvilinear region by breaking the region into infinitesimally thin vertical slabs. In the early 20th century, Henry Lebesgue generalized Riemann's formulation by introducing what is now referred to as the Lebesgue integral. It is more general than Riemann's in the sense that a wider class of functions are Lebesgue integrable. Integrals may be generalized depending on the type of the function as well as the domain over which the integration is performed. For example, a line integral is defined for a function of two or more variables, and the interval of integration is replaced by a curve connecting two points in space. In a surface integral, the curve is replaced by a piece of a surface in three-dimensional space. Thank you. Application that we can apply in our daily life. 1. Application in engineering. Integration is used in many fields of engineering to solve problems related to the motion of objects, the flow of fluids, and the behavior of complex systems. For example, in civil engineering, integration is used to calculate the volume of materials needed for construction projects such as concrete and steel. In mechanical engineering, integration is used to determine the velocity and acceleration of objects, which is essential for designing machines and vehicles. Number 2. Application in economics. Integration is used in economics to analyze trends and make predictions about future behavior. For example, in finance, integration is used to calculate the present value of future cash flow, which is essential for determining the value of investment and determining the cost of capital. In macroeconomics, integration is used to analyze the behavior of complex systems such as the economy as a whole and to make predictions about future trends. Thank you.
Hi, Assalamualaikum. My name is Muhammad Arif Daniel bin Halmun, and my matrix number is 01 F1012. So from now on, I will be doing this question that were given on our presentation. So based on what you can see on this question, we got a graph that shows a straight line that intersects with the hyperbola. The question wants to know what are the points of coordinates that intersects with the straight line and the hyperbola. So in order we want to find the coordinates, we need to find what are the x coordinates. So first of all, we need to do is join both the equation together, which is y equals to 10x minus x squared minus 8, and the y equals to 10 minus x. So after we join, we got negative x plus 10 equals to 10x minus x squared minus 8. So from now on, what we can do is we need to move the left hand side to right hand side to make it simplify. So after we simplify, we can now find the x coordinates by using the quadratic formula. So after we use the quadratic formula, we got the two coordinates of s, which are x equals to 9 and x equals to 2. So after we found the x coordinates, we can now find the y coordinates by submitting both values on the ideal questions. So for me, I choose the straight line question because it is more easy to do. So after we submit both s values on the questions, we got y equals to 1 and y equals to 8. Now we have found the points of coordinates that intersect between straight line and hyperbola, which are 2, 8 and 9, 1. So from now on, I will be passing the next question to my teammates, Megat.
Alright, thank you to Arif for answering question A. For question B, which is to find the shaded area R that is bounded by a line y equals to 10 minus x and a curve y equals to 10x minus x squared minus 8. So the answer is using the formula area, which is y, we must find the y upper and subtract with y lower. So in this case, y upper is 10x minus x squared minus 8. Y lower is 10 minus x. So now solve this equation and we'll get 11x minus x squared minus 18 dx. And then the next step is to differentiate this and we will get 11x squared over 2 minus x cubed over 3 minus 18x, and bracket we put 9 and 2. And then the next step is to put the limit inside x. So we'll like this 11, the x is substitute to 9 here, x, and then here 11 is substituted into 2. And then solve one part and one part, and then we'll get this, and the final answer will be 57.111667. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amirul Hizzuan Birasli, registration number 01DM23F1027. Now we have come to the end of our presentation. So from now on, I will take over this presentation and at the same time conclude or summarize this presentation, which is about integration. So integration is a fundamental mathematical concept that affects numerous aspects of our daily life in small yet significant ways. Beyond helping with mathematical problems, integration has real-world application in a variety of fields that influence how we interact with the environment. Integration is important for everything from planning effective urban areas and forecasting economic trends to allocating resources as efficiently as possible, and even for routine chores like budgeting and cooking. It gives us the ability to precisely and effectively navigate the complexities of daily challenges, analyze complex systems, and make well-informed decisions. In addition to becoming proficient in mathematics, we gain useful tools for empowerment in our daily lives by comprehending and embracing the principle of integration, which empowers us to approach tasks with confidence, creativity, and precision. So that's my that's what my point of view, which I have summarized from our presentation that we have learned from this topic. So I hope it gives us something that are valuable that we can take for our future. That's all for me. Thank you for your attention.